1.1. What is statistics? When you hear data like 50% of first marriages end in divorce, we analyze where they came from and how they were obtained. That is statistics. Um, Collecting information or data is the first step. Organizing and summarizing it is the second step. Third is analyzing to draw conclusions. And fourth is reporting the results with a measure of confidence. And data is simply just facts or propositions used to make decisions. And they can be numerical, like a physical quantity, like height in centimeters or height in feet, or non numerical, like gender. And then um, they both describe the characteristics of individuals. So, why do they matter? First, they can counter anecdotal claims with real evidence. So someone might tell you that phones cause brain cancer, and you can use statistics to prove otherwise. And help spot misleading studies such as bias samplings. And the third one is basically the same as the second one. Um, there can be lurking variables, which we'll get to later. And they're simply just like confounding variables, which are just hidden factors influencing results. That's what lurking variables are. Confounding variables, uh, factors that are included, but it makes it hard to fully attribute the cause or the effect to one cause. So we have to understand variation, and the idea is that data always varies between people and even within one person over time. So in a case study, which we'll get to later, um, it's going to be over time, and people are going to change over time. So variation explains why different surveys can show different results. And then take math versus statistics. Um, Take the equation 2x equals 4. There's only one right answer, and the answer is going to be 2. X equals 2. But statistics allows for different correct answers depending on the sample. There are confidence intervals instead of certainty. So we can be 95% sure that the average commute in Dallas, Texas is anywhere from 20 to 23 minutes. And it's much like an inequality. Um, like x is greater than 2 where there can be multiple answers. Obviously x greater than 2 still has infinite answers. So usually it'll be capped much like this percentage variable right here, which is the certainty, the measure of certainty. Um, so you can think of statistics like inequalities where there's not just one answer, and this inequality allegory comes in later as well. So we have to explain the process of statistics, and the first step is identify the research objective. So we define the question and population, and that's how we're going to obtain our data. So first, to collect data, we don't use the entire population, because most of the times you can't. I'm pretty sure all of the times you can't. Um, so if we're trying to measure um, how much um, money people spend at a certain restaurant, we can't measure every single person who comes into the restaurant. And otherwise, if we could, there would be no point of statistics. Um, so we use a sample, which is simply just a smaller portion of the population, because studying everyone is impractical, as mentioned before. We describe the data using descriptive statistics like graphs, tables, percentages, to summarize the data, and we make inferences based on the data that we have. So if 4 out of 100 people spend over $20 at a certain restaurant, then we can assume that 4% of people will spend over $20 at that same restaurant. So the key terms you have to understand is the population, which is the entire group studied, a sample, which is just a percent of the population used as a subset. Subset is just a portion. Individual is just one person or object from the group. A parameter is a numerical summary of the population. So basically like qualitative data, or as we've mentioned before, um, numerical. And we have parameters, which are just or statistics, which are just numerical summaries of a sample. So again, qualitative, And well, I guess, yeah, percentages are all qualitative, but a statistic is just a numerical summary of the sample, um, which basically is before we make the inference. The parameters after we make the inference and apply it to all people. So descriptive statistics organize and summarize data, and inferential statistics uses that summarized data to make conclusions and draw conclusions. So then we have qualitative versus quantitative data. And it's basically like what we mentioned before, something like numerical or I believe in like science they use the term like a physical quantity where you can measure it using a specific unit of measurement. So typically qualitative is categorical and quantitative is numerical, and then that's going to appear a lot. Um, something like um, something like many people wake up in the morning. Describing an action is going to be qualitative because it describes a quality, or more people are happier throughout the day. That's going to be a quality, or something that can't be described using simply numbers. Quantitative is numerical and is what the science term a physical quantity. So discrete means countable values, which just means that it's one specific point, and continuous means measurable values over an interval. Think of inequalities. So we can take we can apply math to this. When x equals 3, that's discrete because x can only equal 3. But when we have something like y equals x plus 2, it can be any value. And therefore, there's no one specific answer. Discrete means one specific point. Continuous means it applies to a certain range, you can say. So there's 4 levels of measurement. There's not nominal, which is just names and categories, ordinal, which are categories with order, intervals, which are numbers with meaningful differences but no true zero, um, such as temperature and Fahrenheit, and ratio, which is like an interval but with a true zero, um, allowing ratios. So things are like age, weight, day studied, time elapsed, because we have a final and initial point. Lastly, we have to understand the difference between good and bad statistics. Good statistics use clear research objectives, proper sampling, and correct analysis. Misuse by samples typically include things like lurking or confounding variables. Confounding variables can still be misused because we can't fully attribute a specific amount of effect to the cause because there can be multiple causes, and that's what a confounding variable is. And understanding what type of variable you're dealing with dictates the correct method to analyze it.